Here. I'm Nick from Telnix. Again, we're hiring. So you saw a slide like this yesterday when I was up here, probably at about just after lunch. You were all asleep. So maybe hello again for the first time. That's me. Twitter, GitHub, @NickTimko. So yeah, like Python's great. So we can kind of directly use it in a bunch of contexts for like NumPy, data analysis, web hosting, everything. But sometimes sometimes Python's not enough, and you need to do something else. Thankfully, we can use Python to glue together other programs, both on kind of the level of kind of C libraries, so like TensorFlow and NumPy are all using kind of C beneath, or Fortran even. But sometimes it's like there's just a binary, and we need to call that binary to do something. So my talk here is basically to convince you that you can use Python for what you might normally use a shell script for. If you just need to do a couple commands, a shell script is like pretty quick and it works reasonably well. But once you start needing to add in things like logic and everything else, it blows up. And even kind of the shell that you might use on a machine, there's a million shells out there. All of them are kind of subtly incompatible with each other. The kind of like Z shell types or like bash shell, Z shells are close enough. And you can like bash 3x to 5x are all intercompatible if you use like a restricted subset, but maybe you'll ship it, you'll develop it on Ubuntu, which is bash 4, and you'll ship it to someone on Mac, and it'll like not work there because some weird syntax is like new. And then like Windows, of course, if you need to support Windows at all, good luck. It's better just to if you can use Python, just use Python to do your commands. So like let's talk about these incumbents and like what they're maybe good at and like why we would use them. So the pro is like you'll always have a shell. Like one of those shells will be there. So if you write a kind of really basic sh script or like dash in Ubuntu, and also like a batch script, not bash, B-A-T-C-H, which is for Windows. Like you'll be able to kind of run one of them. And if you look in, for instance, the like Python virtual environment, it generates like an activate script for you. It'll generate an activate.bat script for Windows, PS1 script also for Windows, and then also a shell command, and possibly fish. So because like the shell is there, and that's typically what you'll be using. Plus also like the process control is like pretty easy with the pipe. But there's also like kind of a giant downside is you have like one type and the syntax is kind of very arcane. And if you do something just like add a space somewhere or like quote something like just a little wrong, like you can introduce like really kind of weird bugs. Some of those might be like security vulnerabilities as well. I think like I have and even if I don't convince you about anything else, like you should at least use like shell check, which is this fantastic tool. It's written in, I think, like Haskell. Yeah, Haskell. And this will basically make sure that your code is not, your shell code is not that bad. So if you look at all these, here's like the common gallery of bad code. So like all these things that look reasonable, right? But they're all just like subtly broken in some way. And then you'll typically like discover this in like when it maybe deletes your working directory or something like that. So it's nice to shell's good. If you want to use shell, use this also. But then also like we could also use Python and maybe just sidestep all of this problem. And kind of if we discuss how we're interacting with processes that are not ourselves. Typical inputs to processes will have some arguments. The working directory, environment variables, and standard input, which would be like if you're piping into a command or typing it in with like input, the function call, and some files. Typical outputs, standard output, standard error, execode. There's also sockets and such, like if you're running a web server. But here, like I'm mostly going to talk about just kind of interacting with a process like that you'd run locally without like a lot of stack components. Yeah. So. And we'll talk about this both like from two sides. If we are the parent process, and also if we're the child process. So being the child process is much more common to us in Python. So what happens is that we will basically be the child here and receive some arguments, a working directory environment from the parent process, which might be shell, for instance. So if I go over to my shell here and I type Python, the shell is the parent process, and the Python is now the child process, and they're directing standard input and standard output, standard error between them to kind of work. And then when the child process dies, it'll exit, and then the parent process will wait for it just to figure out what this exit code was. So yeah, if we want to be the child, how do we kind of get these inputs that are, that I claim are familiar, and hopefully they are. So kind of the raw inputs that we might have, they're in sys.argv, but hopefully, maybe we've started to use argparse, click, or docopt. I'm sure there's others out there. I don't know if, does anyone have another favorite argument processor they like? No one? No. Come on, Ming. No. All right. And same thing with the working directory. The working directory is maybe used a little bit less, but we can get the current working directory, which would be equivalent to pwd in the shell. So if I present working directory, and I can also cd to around, so to change the directory. So these commands are very equivalent. Environment variables, there's the OS environment. A lot of the stuff is typical that we've used before. Standard input, the input function that we've used. Now that Python 2 is dead, we don't have to worry about input sometimes being raw input and it'll evaluate functions, right? Should double check that sometimes, just in case someone does try to run your program in Python 2, and it does run. And also files. These I'll skip for later, but they kind of skip out of the process hierarchy, and they're more out of band, where they're interacting with the OS to open a file handle, akin to standard output and standard error. Outputs, standard output, standard error. It's very easy. It's print exit codes. We can basically sys-exit with that code. So that's easy stuff that hopefully we're a little bit familiar with. Here though, I'll try to talk you through some more the other side of it. So if you want to be the parent process to other processes, to basically be able to control some children to do your bidding. So how do we basically parent processes? Again, we said, the same issues. We want to kind of take inputs and provide outputs, except we're doing that the other way. So we'll see how to do that here. The kind of module of choice that you'll use is in the standard library, if you would like to go that way. So that way you just don't need to have any external dependencies beyond Python. I'll talk about some more powerful libraries in a moment, but for subprocess here, if we can do something just run a git command to check what revision we're on. What we'll have is arguments that we pass into it. We'll pass them in as a list that we've already broken up, and I'll talk about this, how it'll avoid kind of shell injection. And then the working directory, we can cwd, so that way it's set up where we want it to be. Environment variables, if we want to pass kind of anything bespoke into it. Here I'm just kind of setting one more environment variable A, and then also, or setting it A to B, and then basically filling in everything else from the kind of current environment, so it inherits. This input's just kind of fluff, an example. And then, yeah, so then this is it, and with this we can run a command. It's running a git rev parse, which is easy, but we could do something run a sequence alignment for DNA that we have, or kind of generate some 3D renders with some other program. You can do anything you want with this. This program that you're calling does not have to be written in Python. It doesn't need to know Python exists. You just basically need to be able to run it. So we can use this to fuse perhaps anything else in a tool chain that we have to anything else that we want to run. And with Python, it's very quick to configure. It's very quick to iterate with. So we can basically build up kind of tools just for ourselves that make our lives easier. And yeah, in this case, we're getting output, thankfully no error, and then a return code, which will be like typically for Unix, it's 0. 0 means success, which also in the bash shell, 0 means true, which is like another fun like inversion of sanity. So, and the other kind of mode that we might have is if we want to just launch one thing. So let's say we're going to start up, like do some, like let's say, like Blast. Blast is a DNA alignment tool, and Blast will eat up tons and tons of memory, like all that it can, so that way it's like it can be a little bit more efficient to do the sequence alignments. If we want to just maybe configure it, because if you ever kind of run Java programs, you know that there's like a million, -x commands that like let you control, the memory management, like how much, virtual memory it can have, kind of the whole like JVM you can configure. A lot of that is, you can maybe like put into a shell script, but you can also, do something like that and combine it with arguments that you might like run. If you're storing your like input data in some existing file structure, you could use just a little bit of Python to like sort out, like where's this file, like pump it in as this is one argument, this is another argument. And rather than the subprocess way where Python will be running the whole time, if we use os.exec, that will replace the process entirely. So there's like the operating system call, I think it's like exec, and like this star, there's a bunch of variants of it. The process replacement that, for instance, Linux does will just, it'll drop the code that you're running and then replace the same PID with this other process. So the overhead is basically none, it goes away. And you can just like launch some complicated executable that might be very, very resource demanding with no overhead. So you get kind of all the kind of benefits on the front end of being able to like configure it, deal with your paths, like your data that you want, and then just like fire and it'll be just the process. How we do that, for instance, it's flipped a little bit around. So if we want to kind of change the working directory, we change it beforehand. And then when we call this os.exec command, the process is like Python just ends. Like Python is not running anymore. And the standard input, standard output, standard error, and exit codes, they're basically just replaced in. So you could have read something beforehand and like printed something as well. But once you call the os.exec, your Python is just over. So it's handy in that when you want that kind of thing. So let's kind of poke around a little bit here. Hopefully not too much hilarity. There we go. Yeah, so here's like the kind of, I'm launching it in the notebook here, so I can prove to you that it actually does work. It's just that easy to run Git, and if we want to, check out anything else that's possible, like what was my last commit, and then I broke it. Yeah, all right. So. There we go. All right, so here's an example of a script that is, going to do something like, we have a file, like let's say this is a kind of a continuous improvement like pipeline that we have, do-it-yourself continuous improvement, dicey. So we have some fantastic code right here. It's a little problematic, but we'll run our kind of lovely tool on it. So like the kind of expected easy.shell here, we're just basically pointing ourselves at it, linting it, and maybe we want to like check it for style formatting. So this is kind of like a really first pass at just a shell script, which is acceptable. Like if you're not doing like anything super fancy, this would work. Except also you might say that I should have quoted this because things might happen. I don't know because I'm not really good with shell. But even here, we see that it is failing because of undefined variable and some warnings and everything else. So yeah, sure, I can go in here, I can like fix the name error. I can maybe get rid of like an unused import, and like maybe I'm happy with this. So even if I run the command again, it's only failing on Pylint, and it's only complaining about these like C convention issues, and maybe I don't want that to actually like kill the whole pipeline. So you're seeing it's not even running black at all. It doesn't even get down to this black check. So to get around that, like that's because Pylint is returning this kind of weird bit mask, where if there's a 1 in it, it's a fatal error. If there's a 2 in it, it's a warning. If there's a 4 in it, it's I think convention, refactor, on and on. So in order to get around that, we need to kind of go from this fairly tame shell script and do this, which it took me like far too long. Probably don't want to admit it, to come up with this subshell. So here we're using bash because we can't do the correct bit math in shell. So what we do is we set a default for the value, and then we run it, and if it did succeed, then we set the return value to that value, i.e. if it wasn't 0. And then we like do this bit math. So which is like the fatal error, usage error. And this is like very like kind of fragile code. I'm not like if I do something like that or like tweak white space at all, if I forget one of these semicolons, it'll break. If I just threw this in here, someone might not be able to kind of customize it easily. And this is just like Pylint. Like Pylint, a lot of people should be running. Or any other program, and it's it's really touchy. The other easy way is you just like basically like remove error exit, but then that's a whole new set of problems. So yeah, like what we can do here though is use Python itself to come up with a similar kind of result, but instead of using kind of weird bit masks in Bash, which have like, are tricky, we can do it kind of much more clearly and succinctly with Python code. So if I go back here, I can demonstrate that the equivalent one was also happy for, got past the linting, so it basically did that bit mask and was, good enough here. And then it said it also complained because it wants to reformat it. So we could like black, everything. Paint everything black. Ta-da! Then when we run it, success. We get success. But if we did that with our like kind of dicey file here, well, I fixed the black issue, so it didn't say much, but. I'm not even calling black. What to do? Yeah, so we get that. So hopefully this is like might kind of hopefully I'm demonstrating it's sometimes easier to perform some tasks in Python, but we can also kind of like cheat even a little bit more because calling subprocessor self can sometimes be tricky. If we want to do things like run multiple processes at the same time, where we're kind of running in the background asynchronously and like letting them do work. You might still need to use subprocess in order to you can use popen, which is the kind of underlying object that like run, check output, check result will use. But if we just basically want to call a couple commands, there's also Invoke. So Invoke is a fantastic tool along with like Nox, which I've also started to use, which kind of simplifies a lot of it for you. Nox is kind of like Tox, but you can also, there's more Python in it, so you can like do these basic kind of if-then constructs without needing to Tox uses what is it does it use YAML? I forgot, but the configuration is not actually Python itself, so we can be a little bit more powerful and expressive with Nox, which uses Python. So, and the kind of equivalent of the dicey in Invoke here, I'm being a little bit more fancy to like describe every single possible exit code here. But if we define a tasks file, and then within it we from Invoke import task and then decorate functions with it. The tasks take a context, and then we can run a command via the shell right here. And then this warn equals true means it will return to us the exit code rather than just dying. So if we do, it's like invoke is the, or invoke is the command that you use to pull, to basically like launch invoke. Invoke looks for task. Task is a module or is a full-on package in the current directory, and we'll fire that off for you. Excuse me. So you can kind of also have it be a single file, like just a tasks.py, or like a tasks package with like multiple subtasks if you want to get like much more complicated, or just structure your code a little more cleanly. If you have like testing, running it, maybe like running it in a virtual machine, running it in a container, like with all these kind of different contexts, you can like start building up your kind of tool chain. Yeah, so I guess I was blazing through this talk. So yeah, I don't know if I could probably just open the floor up to questions, because I am, yeah, this went very quick. Yeah, so does anyone have any questions about subprocesses?
I could add something probably and share my experience on it.
Okay. Yeah, I think the camera guy would like a mic.
Hey guys, so my background where I'm coming from is network engineering. So I bit differently look into things when you doing daily stuff like you programming all the time. But what I faced before, my main issue, sometimes I need to use bash script because my network devices doesn't support Python internally. So my best approach is to run remote bash script on it to do some changes. And you have no options. You just have one option in that case, yeah?
Mm-hmm.
And my toughest stuff probably, when you switch your brain into shell script, it's so hard to come back to Python because it's so different language. It's just, you forget how to define function even, after a week in shell script, so it's tough. With subprocessing, I had some fancy stuff done. So I had some migration stuff in my project, so I needed to do multiple changes on multiple things at the same time. So I prepared something that I could inject into multiple bash scripts. So I'm running Linux laptop. I have 3 displays connected. My Python script opens multiple shell scripts. It's placed wherever I want. So it's calculate placement on the screen. All the shells is divided nicely. And it has control of all my bash scripts, so it can SSH into network devices. Mm-hmm. And in background of that, I'm running script, which is bash stuff, which can log output into file. So when I'm reading that stuff from Python to analyze what I'm getting back. So I have 2-way communication with every single device, and I can make decisions from that. So it was really awesome and fancy. Mm-hmm. Okay, so that's my experience, guys.
Yeah, it sounds cool. Like you can go, completely nuts and like build like really kind of advanced like monitoring systems, just from parts that you have lying around on your machine. And it's true, yeah. Because like you mentioned, if you're connecting to like a network device that doesn't have like Python on it, there's also kind of a derivation of Invoke called Fabric. And Fabric's also like pretty handy, where you can you can write the same commands kind of like you were doing here with Invoke, but you just call them on the remote. So it will SSH into the host for you, run commands like check the output, check the like return results, kind of do the communication. So yeah, Fabric's also pretty handy. Another question? Get the mic. I had like one more demo I could also show with after the question too. So
It's not even a question, it's a response to the other one. So
okay.
I ran into similar problems where you're basically trying to deal with tiny machines that no matter how good we get with MicroPython, it's not going to be worthwhile loading onto those things, even if you can install stuff. But Paramiko is a lovely little module. And basically, the idea is that you're able to running your Pythonic SSH client within your parent, in this case, connecting to the remote machines and basically doing it to remote exec, where you've then got your standard out and standard error coming back. So yeah.
You know what's the first rule of screen scraping? Never ever do it.
Yeah, and as a comment, I guess, to that, Paramiko is the library that's like under Fabric. So Fabric just kind of makes it look a little bit like shinier. Do you have a question, sir?
Yeah, so I do a lot of the stuff you're showing here. I use subprocess a lot, but one of the things I find is if I'm kicking off a lot of parallel scripts, so normally what I do is I'd write a shell script that would have a for loop and maybe kick off 10 different long-running processes in the background, and I really struggle to do that with subprocess. So do you have any kind of tips or hints as to how you would kick off a bunch of parallel processes with subprocess?
Yeah, I'm thinking, like, if they're, like, is it for kind of like a service that you actually want to run? Like kind of 10 different like workers of a like Django or something, or something like that.
Yeah, essentially, I'd be kicking off 10 different runs from different tools. Well, probably the same tool with different inputs. If you know what I
Okay.
mean.
If like, and are you doing kind of like stream, like piping? Like, do you need to pipe out input between them?
I don't need to pipe. Yeah, I'd probably need to capture the standard output, or else I could just key that to a log or something and check it afterwards.
All right. Like beyond, like I would initially reach for using like subprocess.popen, and like and that's kind of like that's the underlying kind of primitive that the run is using. But I don't know like if like has that not worked for, because like you can kind of popen, it will launch the process and just return immediately, and the process is running, doing its thing. But like you can basically kind of come back in Python and launch another one, or start interacting with that process. So I don't know if.
Yeah, so I think. Yeah, I'm not 100% sure how that would work. So let's say if I want to kick off 10 subprocesses in parallel, I'd have to kind of create a loop. Would it kick them off in parallel, or would it wait until it does each one of them one after the other?
It will, like, it'll launch it, but then it will return to you. It'll be running, and you can kind of hold on to that process handle, but the process is running independently.
So
So like the kind of popen is like pretty quick, and then you just get back the kind of like record of that process.
So would popen be equivalent to doing xterm and then running the script in xterm?
In X.
So if you do.
Kind of.
Demo if I can manage to get that screen, the resolution of my script, which is opening multiple terminals and have two-way of controlling processes, kind of.
Okay.
I have it in my laptop, I assume, but I don't know. Can I make it working? So if you want to chance and see.
I don't know. So like I guess just kind of like.
I can share my code.
Okay, yeah. So like if you see right here, like I'm like running this like sleep command. It takes about 3 seconds to run. But if I do like popen here, it will kind of return immediately. So the process is like this popen object, and then like I'll be it's completed successfully there. But if I do it and then I wait for it to finish, then this is kind of like more synchronous. Versus like here where it's taking 3 seconds with the little asterisk. Here like this is fast, and then it's like actually sleeping here. So you could basically have a loop where you just create a bunch of processes right here. So that ran basically instantly. And I guess like one kind of final demo that I can show you where it's like you're doing something completely different to fuse together components with Python. It's just this kind of like fun little script where if maybe you want the user to enter some information into a command line that's like more than just what input could grab. So I haven't like used it kind of in anger yet, but we can just like launch VI or Vim, probably be less weird. And then if we just call Python, so here it launches Vim for us, and we can kind of do whatever we want. Like et cetera. We can like copy stuff. I don't know. If I was one of my coworkers would probably be screaming at me from across the Atlantic because I'm not using the commands right. And then we can write it out, and Python just grabbed it here. So we grabbed the output that VI saved, and then just printed it back. So we could use that for something else too. So it's kind of here's like a vignette that we can kind of maybe take away. I don't know if there's any more questions. Okay, you sir. Then.
Have you any hints with working with non-blocking standard out, standard error when you're spawning off multiple background processes?
Yes, that's the one thing I'm confused by is in this, like the docs, the standard library docs, it's telling you not to use, I think like communicate, because that can sometimes block because it'll buffer everything for you. So I don't know if you're just kind of supposed to use like the raw like process dot like standard output, standard in, standard error kind of file handles, and then like you can kind of route those yourself. Like blocking, I don't know if like
The background process blocks right into the pipe unless you drain it.
okay.
And if
So
I've got 5 processes,
okay, so you need to
writing
actually
all
be
the code to
servicing them.
drain it is a pain in the neck.
Okay, all right, yeah. So that is like the one thing that like the pros of the shell that I mentioned is like the pipe is like fantastic. It kind of does a lot of that for you. I haven't had a lot of experience with like there are other libraries out there beyond like Invoke and Nox that are kind of do actually overload the pipe operator. For instance, like if you were at the Magic Methods talk yesterday, the pipe operator is like dunder or, and you can they'll use that to actually like handle that for you. But I don't have too much experience with those.
So did you name one of those libraries there, Ryan?
Shoot, I see them pop up a bunch.
Okay,
in,
I can
like,
do some
Python
searches, no problem, if you don't know them.
Yeah, I'd
Cheers.
have to like Google for it. We can talk afterwards. So.
We still have 5 minutes. Last question, I think.
Yeah, one more question. If anyone wants to try to stump me or
Okay, back there.
complain about something, offer up a good pub suggestion later. I heard Dicey is like a really cheap dive bar around here.
That's correct. Yeah, I think one of the problems I have is I'm usually testing out shell commands, and I might have like 3 pipes and a half dozen redirects, and I'm testing that on the shell, and then when I run it in subprocess, you have to turn it into a list of strings. Do you think it's usually safe enough to just split the string and pass that in as a list, or how do you handle translating it back and forward?
Like right here where I'm doing this list.
Yeah.
Yeah, that's something I kind of elided over to, where I have this like slightly fun demonstration of like how you can if you're using the like shell equals true in a subprocess call, you can, and you're accepting user input, you can like inject it and do all sorts of malicious stuff. If the user's not kind of inputting code there, it's usually safe. But yeah, like sometimes like I don't know what commands you're kind of running and testing for, like when I think of 5 different kind of redirections or like pipes in a single command, I'm usually thinking we're using like awk and sed and tr to like kind of manipulate something, which I'll lean more on like Python, or I'll just like pull the string in and like do the string manipulation and return it. I don't know if that's kind of more what you're thinking, but like the difference between like these two, for instance, you can convert if you have a string that you think is like reasonable. There's shlex, it's like shell lexer is like a built-in module. So I think it's shlex.split or .parse, and it'll basically do the same parsing that the shell would do. But then you can kind of like get the benefit of just piping in a string, but then also like it'll be a list, so it won't actually go through the shell. So it'll be a little safer. I hope that was maybe
Sure,
meandering
yeah,
but
I
answer.
didn't know about that.
Okay.
That's cool.
Well, thank you so much.